Welcome back. So, hopefully you've all kind of worked on your blockouts-ish. If you posted something to Canvas, I probably approved it roughly within the hour or the next day, depending on when you posted it. So you should all be good. I think of everybody who's posted, it's all been approved. And then there's just 7 people that haven't posted, but those 7 people are also the people that messaged me, if you sent me a message directly, so that's fine. So everybody should be good to start and get going, because if you don't have a blockout today, you can follow along just with some random shapes. I'm going to be making some random blockouts aside from the one I was just working on, fiddling with. I'll explain how we're going to use that later, and we'll make new ones just so you can see what kind of approach you might take if you haven't started or if you're sort of just getting started. Okay. So what we're focusing on today is high poly. It's going to be roughly an hour and a half of subdivision surface modifier stuff, talking about how that works, what you need to do, and how your meshes need to look to make that stuff work well. And then roughly an hour and a half, and when I say an hour and a half, we'll probably have a break in between the 2 different types. The other half will be sculpting through either Blender, which I'm not entirely familiar with, to be completely honest with you, because I use ZBrush, but I think there's a workflow that you can use that's similar to ZBrush. And then I'll show you what ZBrush is anyway, just in case it's something you want to do. For a career, ZBrush is expensive. I think I paid something like $1,800 or $2,000 for it, way back when. It's just one-time purchase, and it's only really worth it if you're going to be doing this for a career, but they do have a 2-week free trial. Okay, so you can sign up for the free trial, use that to do the assignment, and then cut. Up to you. If you can figure out how to do it in Blender and make it work just as good, that's great. I'll show you the steps to get started in Blender, and we'll go from there. So first and foremost, I need to tell you the difference between low polys and high polys. What is a low poly? What is a high poly? Well, to put it simply, did I start the recording? I did, okay. To put it simply, a high poly is exactly what it sounds like, a higher number of polygons. And our low poly is also exactly what it sounds like, the lower number of polygons. These two are going to work together to create our game-ready models. So in the lab, Sukhbir told you about assets for films and cinema and that kind of thing. He was a little bit confused. So in the way this course used to run is this first assignment would be a film prop more than a game prop, but this year I changed it to make it a game prop because you guys are making games. The film prop idea is because you have to learn subdivision, but we'll talk about that later. This time we're just going to go right into making game props, which means that we're not putting this high poly in our game. Right? The more polygons we have, the more time it takes the computer to render everything. Not something we want when we're trying to work real time with hundreds, if not thousands, of assets on screen all at once, every frame, right? So most of you have taken CG. You know that the mesh pass happens in a draw call, and then you have all your draw calls for your textures and materials and everything else. But the longer or the more polygons you have on the screen, the longer that draw call is going to take. Nanite has kind of removed this as a necessary evil. But we teach you the fundamentals because not everybody's going to be using nanite, and arguably you shouldn't be using nanite unless you absolutely have a good reason to. If your game is entirely made of photo scans that you ran around campus and threw into your game, you might need to use something like nanite, because otherwise you're going to spend an absurd amount of time cleaning up those models before you can put them in the game. I assume none of you are doing that though, and unless you're walking around with $4,000 3D scanners in your pockets, you're probably not going to have that much luck anyway if you're just using your phone. So what is our blockout then? How does this fit into the equation of creating this high poly? Well, our blockout does one of 2 things. It's either going to act as a solid base for our sculpting, or it can act as a solid base for our low poly. Usually it ends up being a mixture of both. So in this case, the one that I've modeled here, you'll notice some slight changes from last week. I can point them out to you so you're not totally lost. I did say I was working on these between the weeks, so you don't be too confused when I come back and it looks a little bit different. But no major changes overall to the structure, right? Most of this you saw me build in class. Some things I did change though, just to prepare this for sculpting and everything. That little indent in the side is gone, so I can flatten that out to help the subdivision surface modifier stuff work. You'll notice these wheels are a lot rounder than the ones that we had before. Before they were 12 edges around. Now I made them 16 just because 12 felt a little too low. What we're really trying to get with these mid-polys, what's called models, is we don't want our silhouette here to read as too polygonal. And that's only really relevant when we're talking about cylindrical shapes for the most part. Flat shapes are super easy to get away with. So this wheel back here, its silhouette is fine because it's a much smaller wheel. So this one's still using 12, and I've got no issue with that. 12 up here, 16 up here. Other things I tweaked, I just made the handle longer and a bunch of other little tiny changes, adding the bolts just for details, right? We want as many individual pieces modeled out as possible before we get into the high poly stuff. That just helps us create our high polys faster. One big question that we'll get into is how far do we push these? And the answer is you don't always know. When working on these blockouts, you may have to change things and go back. So what I'd recommend you do if you're not doing it already, next time you save, don't just hit Control S, hit Control Alt S, I believe it is. And what that does is it saves a future copy. So all the work I do, I'm hitting Control Alt S almost every single time I save. So by the end, I've got like 30, 40 versions of my Blender file. And if at any point something breaks, maybe I want to go back and redo. Maybe one of these elements needs a bigger bevel for it to work properly. I can always go back and find that version of my mesh. It's there somewhere within the different save versions. So start using Control Alt S instead of just Control S. And that way, even though we don't know how much bevel, how far we need to push this model, we can easily go back and then start over and try again. Okay. So when we're starting with the blockout, we end up with these hard edges. Now these hard edges are nearly physically impossible because if you think of this in form of real life, this 90-degree edge is so sharp that if you even dared touch it, you'd lose a finger, right? It's impossibly sharp, and as a result, you get these impossibly sharp edges where the light catches. We know from 2D and we know from computer graphics that light tends to lie on a face and is flat throughout that entire face. How do we get nice rounded edges that catch light then? Well, we have to add some more faces. So here's just a quick example, just using a bevel modifier, just some bevel, a little bit of bevel, lots of bevel. And you can see how it kind of catches the light a little bit better each time, right? So now this edge has gone from this perfectly sharp edge to one that looks like an actual sharp object in real life, something like what the edge of this table would look like, or the edge of, I don't know, your phone or anything like that. It's gonna have a small bevel no matter how sharp you think that object is. It's gonna catch light a little bit more than a 90-degree angle. The issue with this is, of course, this is more geometry. We don't want to add more geometry to our meshes per se, so we're gonna have to bake this detail down. Our high poly model though, we don't care about how much topology or geo we use on our high poly models. All of that information is gonna be baked down to a texture at some point later. So this is not a workflow that you're gonna be using for every single kind of prop. I believe Sukhbir would have used this word with you yesterday, hero prop, or not yesterday, Tuesday. So hero props are types of props where we're going to give them the most love and the most detail. But it's not always practical to do so for a bunch of different reasons. If we're looking at modeling reasons, it takes a long time. When I do these fun projects like this one, I think it took me like somewhere between 2 to 3 months, so just you doing it in my free time, it takes a long time. If you're trying to make every single asset in your game to this level of quality, you're never gonna finish your game. All right, we'll learn a lot more about the optimization techniques when we start the environment stuff, but for the most part, only some of your props are going to be done using this workflow. So the first 5 weeks, this is the workflow for your hero props. This is the big ones, your characters, maybe your enemies, your weapons, anything that's sort of big and important. Most other things, our regular props, these are not getting that same treatment. I can basically guarantee you that very few of these, maybe like the leaves, have normal maps, but the rest of them are using different techniques to try and get away with using less. For example, all of these wood pieces are probably sharing the same material, right? There's no individual baked normals or material. You might have a tiling wood texture that you use for all of them. Same goes for the van. I'm sure it's a combination of different tiling materials rather than a bunch of baked normal maps, because for every normal map you add, you're increasing the texture usage, so that's more Rambian used, and you're increasing the number of draw calls. This adds up exponentially when you've got thousands of things in your scene. So we're gonna have to optimize for games later. Right now, I want you to just reach for the highest quality. Right? The biggest element when determining whether or not your prop is a hero prop or an environment prop is camera distance. So in this quick example, if I'm thinking about like this gun in the player's hand, any guesses what kind of prop, what kind of workflow they're using for that prop, Jaden?
Hero prop.
Obviously, right? They spent painstaking amount of hours sculpting this gun in ZBrush, baking it down, creating intricate textures and details and all these little things, put it in the player's hand. It's like a foot away from the player. They're literally like looking at it. They can inspect, animate it, so they're flipping it every which way, which means it needs to look good, not just from one angle, but every single angle possible, right? Let's take instead these girders in the background, right? So those girders back there that sort of make up the steel platform. Those are obviously not hero props. There's no reason necessarily for them to go in and make such a heavy-duty, intricate, detailed girder, right? It's sharing that same material with the other metal stuff, the metal platforms there in the background, and they're reusing them a bunch of different times. So we've got, I don't know, 20, 30 steel girders all lined up along there. Welcome. So reusability is another element in whether or not we're going to make something a hero prop. There is one condition. I did just say your environment props, things that are far away, they're not going to be hero props. But if you are working on God of War, for example, that is a time when they wanted to reach a bar of quality so high that every single prop in the game, more or less, yep.
With the reusability, what if we have like different environments? Can we use the hero prop technique? Let's say these are going to be used in like a snowy environment.
Sure.
And I want them to be covered in snow.
Yep. Shader.
Just throw a shader on it. Yeah.
Y-up shader, composite shader. We'll talk a lot about shaders when it comes to the environment stuff. I'll explore those options.
Because obviously these are reused everywhere, but that also means that they're reused in muddy environments,
yep.
warm environments,
yep.
dry environments, and cold environments.
Yeah, when we get to the shader stuff, we'll talk all about the different things we can do to make these things more reusable. So for the most part, your stuff should be pretty simple. This is like a one-off case. I don't think anyone in this room will be using this technique. But the one technique where you might want to do hero props for environment, like literally everything, is if you're reaching for an incredibly high level of detail and if you can justify reusing props everywhere. All of these props share one material and they're kit bashable, meaning these small individual props can create an infinite number of other props. Thank you, Jade. If we take a look at all of these different elements, you'll see repetition everywhere. From that yellow texture being reused here, this stone palette being the same, all four of them. We've got these stone pillars that are being used on the gate as well as the bridge. So for them, it was worthwhile to go in and create these intricate sculpts and bakes and normal maps for each of these props because they're going to reuse them so many times that they're no longer impacting performance negatively. They're actually impacting it in a positive way, right? There's no one material for each of these. It all uses the same one, okay? So you have to think really carefully about which props should follow which workflow. Again, I wouldn't recommend you guys do this because this is a ton of work, but we'll talk more about that when we get to the environment stuff. Right, why are we learning this now? Yep, Sylvie.
I just want to ask a question about if we'd use a hero prop for this, like a kind of like a focal set piece, like say you're coming up to the final boss's spaceship core.
Yep.
Would it be worth it to make like that core, that set, like kind of like focal point of this boss battle, maybe a hero piece?
Sure, there are definitely reasons to. So I can pull up this example later and then go through all the different props that they made for God of War, but a few of them are like the big statues or the mountains, and those are obviously super important. So those did use individual normal maps and sculpts and things like that. Kyle?
Sorry, I also just wanted to ask, in games where it's possible, like say you pick up an object and then it physically shows it to you super close, that might be where hero props needed, but then you also hold it later, would it make sense to do one rendition as the hero prop and then one as the more common prop, or just keep the hero prop?
That's actually a fantastic question, and we do typically do both, but what we do often in games is we'll go for the highest quality possible for something like that in particular, not for everything, but for something like that in particular where it might be on the ground sometimes, it might be in your hand sometimes where you're looking at it. You can either go for a mid poly, which works in both situations, or you can do like Starfield, for example. People give that. You've seen this Starfield sandwich? Yeah. Very common practice. Everybody shits on the sandwich, but like that's how it's supposed to be done. That's not the model they actually use in the game. That's the model that they use in the inspector when you're looking at it from 2 inches away, right? The actual game model is a much dummied down version of that. We use these things called mip maps and LODs. So with using LODs, we create the highest level of detail, and as an object gets further away from the camera, its level of detail, the number of polygons, the texture density will all decrease as it gets further away. So Unreal does that by default. Unity tries to do that by default.
It doesn't. You need to set it up. You need to go into the object.
It's a pain.
Define that it has an LOD.
Yeah.
And then give it all the models and textures that it would have at each distance.
There's an add-on that does it all for you. But yeah, my recommend if you're using Unreal, it's no problem. You don't have to think about it too much. You just have to set up the like LOD distances. But yeah, it's the same thing. So many of these games, if we look at Super showed you NoClip, I believe, or he was talking about it and he posted it in the chat. NoClip's a fantastic resource. I'm going to be using it later when I show you guys different environment stuff. I always use Skyward Sword as an example because they tried so many interesting techniques. Skyward Sword just recently had a HD remaster. It's the same textures they used 20 years ago. When they generated those textures 20 years ago, however long ago it was, they generated them in 4K, right? And then the ones that end up on the Wii are in 1080. They map them down, but they always have the highest resolution because you get a better result if you start with the higher one and dumb it down. So that's basically how that stuff goes. Right. So why are we learning this now? Well, we need a good combination of both the hero prop stuff and the non-hero prop stuff. This is the environment we made last year during this class. I made it in the labs with the students. So this is kind of what we're going to do this year, but obviously I'll start a new environment. In this scene, we have obviously a combination of things that need hero prop work. Statues, very high detail, something that I can reuse a bunch of times, but realistically it's something that is a point of interest, right? It breaks up the monotony of all this brown, something the players are going to look at closely, something that is worth having a normal map for and an individual material. Literally everything else is one texture. That's it. One trim sheet makes up the entire rest of the environment, right? I don't need super specific texture, material, sculpt for this table, or that pillar, or that awning, or any of it. It's just one texture, right? So we're gonna learn about optimization techniques. This is an extreme example. This is just the length I go to give you an idea of what's possible. So how do we create variation? Well, we use things like shaders, right? So all of these pillars have individual shader masks that create different like levels of wear and tear. The material for the text is just a shader that shifts the UVs around to different names, things like that. We'll learn about that later, but ultimately we need a combination of both these hero prop modeling techniques and these environment modeling techniques. Okay. So the main takeaway for this bit on high poly models is that this is not how you're going to approach every prop, right? But I want you to learn this now so you have an idea of how to achieve the highest level of quality possible, right? Because if you can do this, it'll be very easy for you to do the simple stuff down the line. Are any questions for this sort of stuff at all? We've asked a few throughout, so mostly looking pretty good. All right, then prepare to make a high poly. If you have a blockout, I'd recommend kind of opening it up. If you don't have a blockout, you can model along with me, and I'm just going to make some random stuff in a bit once we learn about subdivision. So subdivision surface modeling is a type of technique that is mainly used in film. This is why some of you got confused. We don't necessarily need to use subdivision techniques for our models. This is an option. So I'm going over subdivision first and then sculpting. Either or works, depending on what you're making, right? What does subdivision actually do? Well, just like the title card insinuated, turns one face into 4 faces. Very simple. And it's going to do this for every single face that you have. So I applied a subdivision modifier to this, but you'll notice if you make a plane and you apply a subdivision modifier, you won't end up with this. You'll end up with this funky looking circle. I can do it right now to show you. The reason for that is there's actually 2 different types of subdivision surface. So if I go ahead and add the subdiv by default, right, we end up with 8-sided circle, right, from our plane. Let me switch it over to simple real quick, and then if we turn on the wireframe, we can see what's actually going on here. Right, so now my one face has been turned into 4. There are a few things to notice about these 4 faces. The big one, they're all quads. And this is why subdivision modeling is not fantastic for games, is because you have to use quads everywhere. And in games, we like to optimize, so triangles are usually a little bit more ideal. Quads are great for working with the model, but once we actually get it into engine, we want it to be triangulated. So we can take a look at this simple version, and it's pretty easy to understand. If we switch, though, we'll see Catmull Clark. You all took modeling and animation system, or not modeling, math and animation systems, whatever the Dr. Hogue course is. I'm pretty sure you do have to explore what Catmull-Rom curve interpolation is there, but just in case you weren't, we're going to learn about it anyway. For every level of subdivision you add, it's going to take every single face and turn it into 4 new faces. This makes it exponential. So when you're first learning Blender, probably in modeling 1, and you click subdivision modifier, you probably crash Blender because you just kept going. And then at 6 levels, you're at 2 million polygons and Blender crashes. We're not going to go that far. We're going to stick to like 1, 2, or maybe 3 if you're feeling extra crazy levels, because the shading models will carry a lot of the rest. And for our purposes, we never really need more than this many. Right? So you see our cube turns into not a cube with a bunch of faces, but a sphere with a bunch of faces, and this is because of the Catmull interpolation. What are we looking at here? Or more likely, why am I explaining this to you? Well, if you can visualize where the edge is going to go ahead of time, I'm hoping by understanding the math behind it, you'll kind of get an idea of where the edges are going to go just by looking at them. And if you can figure that out, the modeling process becomes a lot easier. So apologies if you don't like math explanations, but here's a little bit of math. No numbers though, I promise. For every interpolation, we're going to use 3 points. Our main point right now is going to be point number 2. So we take a look at point number 2 in the corner. We've got a directional vector to vertex number 1, and another one to vertex number 3. Simple enough, right? Every single point is going to be doing this. So you can imagine point 3 is using point 2 and that point over there. Point 1 is using point 2 and that point over there. So for every single point on your mesh, it's going to grab the closest 2 in either direction and use those to determine where to go. When we add the subdivision modifier, right, we're cutting that face into 4 faces, which means we have to add 2 new vertices, one in the middle of each of our edges. So I've marked them M with the green. And we've got M1 and 2, which is our middle vertice between 1 and 2, and M2 and 3, which is our middle vertice between 2 and 3. Yep.
Would it also be 2 and 2 because there would be a vertice in the middle of the entire plane?
Technically, yeah, but it doesn't account for that in the calculation beforehand.
All right, thank you.
So you see those little green arrows. What happens is point 2 is going to take the direction to point 1 and point 3. And average them out. And what you get is this new direction that goes in between both, perpendicularly. Each of the other points is going to collapse inwards to where point 2 sort of intersects with them. Right? So you can imagine they're all converging into a single point, which is around the middle. When we add the subdivision, it's going to push those points in while adding more, and that's why we get these round shapes. Right? So we don't need to model every single bevel when we're working with subdivision, because a lot of that beveling is going to happen right here. Right? If you can picture, okay, this edge needs to bevel this much, and you can just put the geometry there ahead of time, your time of subdivision surface is going to be a lot simpler. Right? But sometimes we don't always want this like big, round edge, right? Sometimes maybe we want to control something a little bit better. So what do we need? We need these things called holding edges. Right? The key thing here, I mentioned it uses 3 points specifically. So if we want a closer edge, what should we do? Right? If you understand math, these big directional vectors, right now they're huge. We're going all the way to the bottom of the shape. How can we shrink these? How can we make these smaller? Zoe?
Add a little loop cut in one way to make it like different.
Yeah, we're going to add a loop cut to make it different. We want to shrink those giant directional vectors, and one way to do that is simply move up where those 3 vertices are. Now we're dealing with a much smaller space, right? We're not going all the way to the bottom. We're just going to a little bit down, a little bit to the left. Everything else is still the same. Green arrows are still there. That extra vertex is still there. We're still going to move in on those directional vectors, just a lot less. Okay? So now instead of a circle or a sphere, we've got this rhomboid looking thing. Right? And the goal with sub-D modeling is just creating and controlling your edge flow all the way throughout your model in a way that you can specifically get a size of bevel everywhere you want, right? And then we can obviously up the resolution to get better results. Okay, so here's an example of what a sub-D mesh might look like. Kind of crazy looking, a little bit goofy looking. There's a few reasons for it. Anybody have any questions on that stuff? I know it's like a weird concept. I figure giving it mathematically at first might help, and then we'll actually explore what to use it for and when. So the reason sub-D is so good for film is you can imagine as I get closer to the mesh with my camera, I can just up the subdivision levels. And as I get further away from a mesh with the camera, I can lower the subdivision levels. This works fine for something that's pre-rendered, right? It's kind of like LODing, but in films it's more direct and it's not tied to player movement, so they know exactly when and where they need more or less detail. Here, there's a couple things to notice. So I'll show you another example mesh, and then we'll kind of go over what parts you might recognize as pattern. We've got one here. If you look really closely, we can see like the different holding edges, right? So this edge is keeping this edge sharp. We see in this corner, we don't have any holding edges along here. So this is blending all the way between up here and over here. And we get this big bevel as a result. Right? So these sharp corners, holding edges. Wide bevel, no holding edges, right? Here's another sub-D mesh. Similar-ish in practice, nothing too crazy. But you'll notice something about both of these. Is there anything that stands out to anybody about each of these? Eric?
The left one looks a bit rough compared to the other one, which is a lot more smoother.
Oh, well, this is my actual topology, and that's after the subdivision surface modifier.
Okay.
So the topology, that one is using optimized view. It would have way more topology than that in reality. It just shows the smoothness of it. Okay, but there's two things here that are different than the game meshes that you're probably used to making, or at least should be different. If you've been making your game meshes this way, I'm sorry to tell you this is not the way to do it. One, quads everywhere. The goal in subdivision, you have two goals. One, hold these edges that need holding, and two, every other quad should be as close to a square as possible. The more even your geometry, the flatter the surface is going to be, and you're only going to get the rounding where you want it to go. So generally when we're doing sub-D modeling, we're creating a lot of extra edge cuts to try and make things as square as possible. I missed one on that top block. I probably should have another one to make those squares as even as possible, right? Because we're cutting them into more squares, if you have giant rectangles, the more we subdivide it, the more lopsided it's going to get, because it's exponentially just creating more weird rectangles, right? So squares are ideal when we're working with subdivision. So we want to try and keep our mesh as evenly spaced as possible. This isn't always possible, and it creates some interesting complex problems when we get to actually modeling things, which we'll talk about in a bit. But for the most part, this is unnecessary for games, right? We're only doing it because we don't care about topology on these meshes. If you've been modeling your game meshes like this, please stop. You have so many unused edges, right? We're talking about silhouette when we're using game models, so all of these edges don't affect silhouette. That one, like these ones, those would all be cleaned up, right? All the holding edges, obviously the same thing. Okay. Yeah. So that's the key difference between your game models and the sub-D models. And then the other difference is obvious and kind of continuation of that is that these are all quads, right? Like exclusively quads compared to your game models, which are going to be using a lot more triangles as we get through it. Okay, so there you go. I left this one in the slides with actual notes instead of just my voice, so you can read it and look back at it if you're ever confused. So normally we're thinking about optimizing our polygon. We're looking at creating silhouettes specifically. We're using triangles, and we're worried about having clean meshes. When working with sub-D, our priorities are going to change. We're no longer really thinking about poly count. It doesn't matter. We're not really thinking about creating silhouettes. We're thinking about every intricate detail. And the clean topology, honestly, doesn't really matter that much. Having clean topology will help you work on your sub-D mesh, but at the end of the day, once you hit that final prop shape, even if the topology is out of whack, like the topology on this looks like garbage. But what matters is that the shading is good. In subdivision, we're just looking at the shading. I'm going to tell you different ways and show you different ways when we get to the example, how to examine our shading and see if we are all good in that department. As long as that's good, it doesn't really particularly matter how messy our topology looks. Okay? Any questions before I kind of get started and we'll take a look at what we can do with sub-D? Feeling pretty good. All right. So because our blockout, the way I've been modeling it, is as sort of a game high mid poly, so it's mostly quads, but there are definitely some places where sub-D is not going to work for us, and I've been using the standard old technique of make everything n-gons. So we'll have to sort of pick and choose where we use our subdivision. I'll do something simple like this first, the wheels, and then we'll move into something else like a totally different prop just to demonstrate. So if I focus in on these wheels and we just go ahead and get started and add a subdivision surface, we notice that immediately our object collapses, right? And it's collapsing because of those reasons that I outlined earlier, right? It's looking at all the edges, it's finding the nearest ones, and then it's pushing everything inwards. Okay, let's turn off the wireframe. So let's start looking at adding some holding edges, and it's pretty easy to understand because it all happens in real time. I'm going to add a quick edge cut in the middle of this, okay? And something you should get used to doing when you're working with surfaces like this is if I want to bevel in between each of these, right? If I move this here and then I have to move another one to the other side, I can mirror it, but that takes time. I want it to be even on both sides. The easiest way is to just bevel out the middle, and then now your edges are going to be even towards both ends. So there, we have one holding edge. You can do the same thing. Loop cut, bevel with one, and then start to collapse our edges. Gonna get rid of the shade smooth there. We don't really need it with sub-D. Okay. Getting nice and smooth. This edge, I want it to happen over here, so I'm gonna mirror it to the other side. Every single edge is going to need holding edges, basically. Even if it's something that you want to collapse, it's going to need them at some point. So same thing on this inside. We're going to have to add some extra. You can use the wireframe if you can't really see where the edges end. And we'll just scale this up until we're kind of comfortable with how close that is. Same thing for this side. All right. This is a prop that would be pretty sharp as far as the edges are concerned, so we don't need to go too far. I'm just going into every single area and adding holding edges. Okay, holding edges, holding edges, holding edges. Mirror that over. Right? Looks pretty good, nice and round. If we're gonna finish this off, we would have to kind of come in, right? And remember, we want even squares. So I'm adding some extra support loops just to make sure all of our squares are even. If you can't really see, we can just turn this off and get another look at it. Something like that might be good. And there you go. Right? Obviously, this is a super simple example, but this is just kind of what can get you started. So we've got extra ones in here we don't need. Fantastic. A common pitfall that people fall into when working like this is they'll just like go over here, make a new cube, immediately add the subdivision, and then start working as if it's like a malleable piece of plastic. And this is okay sometimes, but you really need to know what you're doing. So I'd recommend not falling into that habit. Work as much as you can without the sub-D first. And then once you think you're ready to bump into it, go ahead and add it and start adding your edge loops later. right? If you model this way, the issue is, let's say you make this shape and you're really happy with it. I'll do some just weird stuff here. Wow, I'm so happy with this shape. The issue is my weird modeling and my lack of holding edges. The shapes are now so different that if I tried to bake this down to my low poly, it's not going to work. I'd have to go and make an entirely new low poly, which is kind of a pain in the butt, right? Ideally, you don't want to do all that. So I'd recommend working from your low poly first, work it up as much as you can, just like we have been for our blockout, and then find the pieces that can benefit from subdiv and work up from there, right? So we can use a combination of both techniques. We don't have to do one for the entire model. The goal is to just make these nice round shapes. How do we know it's round and looking good? Up here, panel you may have opened before, may have not opened before, we've got a different set of lighting options in Blender. We're not just locked to this default boring gray. We can actually change all that. So if we go to our materials, for working with subdiv specifically, I would recommend going to matte cap. And if you click on this, you'll see all the different shading options and models they have available. And one that's really good for shading like this is this red one. So if I click on this red one, you'll see it makes everything super shiny. But now you can kind of watch this light and see how it deforms to know if your shading is good or not. How do I know if my shading is bad? Well, let's find something and just kind of mess it up. Right? It's kind of hard to catch if I just flip this over. It might be a little hard to catch that that edge is messed up, depending on where you're looking and when you're looking at it. But if we use the red, it becomes extremely obvious because we can see the light improperly deforming. Super specific example, but like if you wrap cars, they'll use these strips of light, and then that lets them know if the light is properly flowing along the surface or if it's kind of bending in a weird way. This is our version of that. So my light is bending in a weird way here. I know I've got something wrong, right? Have to undo that. Okay, so when you're working with this sub-D stuff, I would highly recommend using this shader or something similar to it. If you don't like this one, there are a few other ones that are just super shiny, and it'll give you a good idea of if your surfaces are flat. This one as well, right? The red one is just the most simple, most basic. You can even use the lines if you want, but it's a little bit harder to decipher what's right and what's not. So let's do maybe a different piece. And we're going to do a combination. So the pieces that are very sub-D-able, we can just go ahead and do that. So this is another piece that kind of falls into that category. A little bit more organic of a shape. Easily something that we can use sub-D on, right? So let's start adding some extra edges. One here. I'll mention on this one, another technique for when we're doing sub-D. You'll notice that if we add an edge loop here, it's going to follow the middle of each of these faces, right? That's how edge loop works. That's how it's expected to work. But when we want to do sub-D modeling, we want our holding edge to be even throughout, right? Otherwise, we're going to get a different amount of bevel here compared to here. So if I add it right now, right, this is now getting super round, and this is only somewhat round, right? So what we have to use is often the loop slide. Basically, if I add this edge loop, I hit GG, my thing isn't on. Whoops. Okay. So if I select this edge and I hit GG, I can slide it right down till it's literally on the exact same place as this edge, right? Click. And without unselecting it, I can start to slide it up a little bit. Or if you have the room, you can just hit an axis. So in this case, I can just use the Z axis, and now I know it's even all the way around. All right, so now this bevel is going to be even throughout. We need another one back here to hold this edge back. This is another one of those interesting cases. So we want this to be totally flat. You can delete the faces on the flat side. If I had faces here, it would be rounding them out. Right, causing issues. If I don't have faces there, it will just be a flat surface because it's running out. Those three, it can't find any, right? There's none there, so it just becomes straight flat, which is what we need, right? Because we're gonna be crashing this into the other mesh. We need another one to hold this edge, so we're rounding out here. We can add another holding edge, move it right in, tighten it up. Same on this side, move it right in, tighten it up. Okay, and then I'm just gonna mirror this over. Connect these. Generally, we want to make as big quads as possible when we're doing this. So this didn't have perfect sub-D topology before. I've got these n-gons and everything. So we're going to quickly clean this up as much as possible just to make life a little bit easier. Something more like this. We're just adding enough edges that we can support our newfound edge loops. And remove. Okay. Same thing, we'll quad these out. You typically want to move from big to small, just like anything else. So the big details, we'll add the bare minimum number of vertices for the big details, and then we'll slowly work our way up. At this point, we can punch this up a bit and get rid of the smooth shading, right? Until we're pretty happy with the result. So I'd say this is pretty good. Maybe we want one more here, slid up, just to create a nice sharp edge along the side. Okay, so with this, we're getting an incredible amount of detail compared to what we originally had. And you can tell by the shading. Doesn't seem like much, but when you do it for an entire model, it makes a huge difference. Okay. Something else that would be pretty simple to do is something like these nuts. When we talk about UVing, I'll talk about how to make items like these, because they're all actually the same item, and they share UV space and things like that. Something like this as well. So we can go in here. All right, we'll start by cleaning up all of the parts that aren't quite quad based. So here we can add an extra loop, or we can kind of cheat a little bit. Right, so I want to add an extra loop here. I've got this end and I've got this end, but if I join these, I end up with this triangle, right? Triangle's not good for sub-D. What we can do is literally just add an extra edge, go down a bit, get rid of that. All right, and now this is technically a quad. It's more of a diamond shaped quad, but it's still technically a quad, so it works much better with our sub-D. Okay. We lose control of our shape as expected, and we need to add some holding edges. I'm going to delete the one in the middle because I can use the bevel to get nice even one on either side. And then we'll use that same technique, edge slide, move in. Move it over to the other side. Fantastic. All right. How are we going to add edges to this side? This is where things can get a little bit tricky. We could, of course, do something like this. But sometimes that's not always an option. So our other option for adding edges on the inside of faces is one you're all pretty familiar with, or should be pretty familiar with. Inset it, right? We're isolating that detail. Getting some shading issues, so we know we've messed up a little bit here. We can check to see what's going on. Quad these out. And I think I just have an extra vertex or something. Yep. I notice this does the same thing, more or less. But now we're getting our edge all the way around, right? So our holding edge is going all the way around this face instead of all the way around this face and this face. So you have to use a combination of both techniques. This works here right now because I want this part to stay rounded like this. If I was to add extra edges like here, you'll notice that now I've got this loop that's going all the way down across and across this back part. And I want this back part to be round still, right? But I've got this extra edge from trying to smooth out the top. So in this case, we're going to use the inset, because it won't add this extra edge and lets this top part remain smooth. Okay, a little thing in case you've never done this before, if you hit Shift G, you get a select by different options. So select similar. So in this case, I can just select normal and it'll select most of the faces for me, just so I'm not having to click every single one. You can also use things like flat and smooth, your angles, coplanar, area for finding a bunch of different faces. Let's say you have like a cog wheel and you want to select all the teeth. You can use select by area to select all the teeth because they're the same size instead of having to manually click every single tooth. Or you can just do this. Okay, quick inset. Mirror it over. Okay, take a quick peek. We're mostly looking like all of these squares are even size in surface area, so we'll call this pretty good. All right, and again, it makes a pretty big difference when everything is all added up together. All right, now that we have a few subdivision pieces, pieces like this piece look super out of place. Okay, and we just slowly do this for all of our different pieces. Why is this workflow so good? Well, when we're going to bake, all we have to do is drop the subdivision, make a duplicate, and get rid of all these extra edges. So let's just use this piece for an example. I'll duplicate it, put it up here. When I'm going to actually do my bake, I'll just get rid of the subdivision and get rid of anything that doesn't affect the silhouette. So those don't really, that doesn't really, maybe a little bit, so we'll leave it. This one, not so much. Anything else? This middle one, not necessary. For demonstration, I'm just going to quad this out, but realistically, if I was working on this for a game, I would probably just triangulate everything here. All right, same thing up here, just triangulate everything. All right. Does this topology make you feel uncomfortable? Just like, I don't know if you guys use this stuff or not.
Yeah, I kind of hate that.
This is very common. Like, this is how, if you look at any prop in games, it's probably done in some way similar to this. Like, we're trying to minimize the number of polygons, really, at the end of the day, as long as it doesn't affect the shading. This is super common. You'll see this in all kinds of props. You will not. I promise you, this is how game topology works. We'll go over it a little bit more when we create our low poly about how we set everything up, but the goal is the minimum number. If you guys go into your bottom bar here and right click, you'll find a little thing called scene statistics. I imagine it's not on for a lot of you by default, but if you go to scene statistics, you can now view all of your information, your triangles, your faces, your edges, your vertices, right? Super useful information for when you're trying to optimize things. So if I go ahead and do this up properly, quote unquote, at least the way you've been taught so far. We'll get in here, we'll add an extra loop to make sure that we can quad this out. Quads are fantastic for when you're working on things because it makes it so much easier to work on. But when we're not working on the thing and we're just getting ready to put it in the game, we don't need to worry so much about it. So let's do this. Yep.
Sorry.
No.
I understand the quads for static environment objects, but what about like a character that would deform?
Characters, you do need quads.
Okay.
That's true. That's a good point. Anything that's going to be deforming, like a character or something squishy or some kind of soft body, you are going to need quads for that because triangles do not like to bend in space. For anything else, anything that's static, yeah, we can use this technique. Even if it's static, even if it's animated, but in a way where it's not deforming, so think like the slide on a gun, I don't need that to be quads because the object itself is not deforming, it's just moving in place, right? So something like that, a gun, it'll be all triangulated like that as well.
Okay, I see.
Yeah, no worries. So let's take a quick look. We're at 90 triangles right now as it stands. Cool, fair enough. But now let's say we don't really care about how quadded out it is. We're just looking to use triangles and get this game ready. Kind of need that edge still. We're just looking at like the bare minimum number of edges we need. We don't need this extra one because that can just be a triangle. This can get slid in to make another triangle. There's a quad there. We can delete this and this. This can get slid up. And then we'll triangulate this. Okay. Even this, actually, we don't need that. Great. Here's our triangulated mesh. This is what I would do if I was actually making a low poly for this. All right, here's what we ended up with. So we've taken this object that was clean at 90 triangles, and it is now 36 triangles, right? So this is why we do this for games. You would never do this for film or anything, but for games, this is something we can get away with, and it's good because we optimize things incredibly. This is a small, tiny object, but just from not doing it correctly and using triangles in this manner, we end up saving, it's a third of the size that it was before, right? Doesn't make a huge difference in the case of this single prop, but imagine thousands of props. You're saving thousands of triangles just by changing them. The silhouette and the form of this object have not changed one bit. It is identical to how it was 30 seconds ago when it had quads. It just has triangles now. So something this semester I want you to get used to is using triangles a little bit more, knowing when and where to use them. But we'll cover that kind of more next class when we do the low poly stuff. So we can get rid of that. So that's the general process with subdivision surface. I would recommend now you take like 10, 15 minutes to sort of go through and see if you can create high polys out of any of your blockout pieces, or just mess around with the sub-D a little bit and create some interesting shapes. I'll probably be doing the same up here for the next 10, 15 minutes just to give you more time to get familiar with it, right? And then we can kind of go over the weirdness that is topology patterns and how things get affected when we're trying to move from different a number of polygons to different number of polygons, right? So the name of the game is optimization. For a quick example, something like this. If I want to go from 3 faces down here, right? And because we're trying to make everything quads, it's a little bit more complicated. We can't just make a big triangle. If I want to go from 3 faces to 1 face, we use different techniques like this one here, where we kind of combine all of our 3 faces into one big trapezoid that still only has 4 sides. And we're at 1, right? So this is 3 to 1. And there are a bunch of different other ones that you're going to have to learn while you work on subdivision models. So Sub-D topology guide, pretty common. There's images everywhere, but it gives you a pretty good idea. I prefer this one because it's a little bit more detailed. Where to go? All right, helps you kind of understand how you can get from a certain number of faces to a certain other number of faces, right? If it loads, there we go. So you guys, I'm not entirely too worried about this for your props and things like that, but if you're working on characters, this stuff is absolutely essential. Because let's take your fingers, for example. You need an extremely high amount of polygons to get all of your finger details done. What happens when we get to the wrist? There's no point in having all of these details, and it's going to mess up your subdiv because it's all different densities going from your fingers to your wrist. So you have to use techniques like these ones. I use this one or this one for fingers, usually myself. And then at the knuckle, it kind of goes from 5, from where it was at the finger, to 2, or whatever, right? So this stuff is pretty important. Just memorizing it's not going to help you. You're going to have to actually go in and practice and sort of create these. What I'd recommend you do right now is sort of take an image like this, make a flat plane. So just hop back in Blender, make a flat plane, move it over, and then just start kind of practicing making these, right? So if I need to go from, I just did the 3 to 1 example. If we do like the 4 to 2 example, we start with the biggest shapes, and then we kind of work in, and you can figure out how you would create these. Most of the time, the answer is pretty simple. It's just the knife tool, but You can always add edges after. All right, 4 to 2, I know we need 2 more edges here that are going to get cut off at some point. We cut them off, and then we can use edge slide to slide these over. Oops. Right. And now we've got something that's 4 to 2. They're pretty simple in practice. It's just about getting used to the tools that you need to actually make these. And now if we subdivide, it's not going to collapse on us. Okay. Yep. This one here? This one?
Yeah. Why? What's the difference between the bottom square and the top 2 rectangles?
It's all about the number of faces. Like all of these examples, we're trying to reduce the number of faces, right? So we want to isolate our detail and topology in areas where we have detail. So in the top here, we've got 2 faces. So I don't know, let's say that 2 faces splits off into like a bunch of different things. So if I do like 2 faces like this, it moves over. Sure, yeah. But the main idea with this is that there is going to be detail there. So if I take something like this as an example, maybe I'm coming down from 4 faces up here, right? So now I've got 4 faces, coming down to 2, and I want to go from 2 to 1 maybe. That's when you would use something like that. So now we can draw this out. Maybe it's something's going off in this direction, right? So we can create our triangles that way. Or not our triangles, sorry. Our triangle looking quads. Okay, so these look like triangles, but they do have 4 sides because we've got this extra vertice here. And if we move it out, we get what's called more of a kite shape or a diamond, and that works as well. You'll see I did something similar up here to get this extra edge in, right? This kind of looks like triangles, but it's not. It makes one big triangle, but everything within is a quad. And you'll actually see this shape quite often if you're working with sub D, because if you take a triangle, when you add the sub D, it still doesn't know how to make triangles. The sub D modifier can't make triangles. So what it'll do is it'll turn your triangle more or less into quads. So if we take a quick look here, turn on the wireframe. Right, it's taken our triangle and turned it into quads using that same kind of technique and shape that we just used to turn our triangle into quads, right? Similar enough. So triangles are not entirely bad in sub D. You can get away with them in very select places, but you should get used to working without them as much as possible. It's quite possible to get away, do something like this instead. Okay, so we'll just take a little bit of time, mess around with the sub D, see what shapes you can create, see how the different holding edges will affect things and where you can put them, things like that. Adding holding edges to shapes like this becomes quite complicated because you need somewhere for the edge to flow. It might flow around like that. That might be what you want. It might not be. We can always redirect things with the knife tool, right? That kind of helps us build a corner. Maybe you want to add extra edges somewhere like this, where you've got the triangles, and you have to kind of come in and cut them across and rebuild. So now we're still maintaining the quads, but we have to do a little bit of extra work to get that holding edge in. And we're working out bit by bit. We don't want to start with like a big, huge amount of geo, so we go slowly. right? It's another area where it gets kind of weird because I want this edge to go around this way, but I also want this edge to have details, so I'm gonna have to create an inset. And then just kind of extend it out the bottom. So we can delete this, delete that, and extend. All right, sometimes we get weirdness like this, but as long as your shading is okay, it's not the end of the world. Because this geometry, we just need it to bake. If this was a film prop, I would be shot dead for having something like this left in my sub D model, but it's not a film prop, so it doesn't matter. We're just trying to get nice shading to put on our low poly. So we'll call this the subdivision portion of everything. I'd recommend still taking a little bit more time to mess around with it. And then we'll take a short, yep, what's up, Jacob?
How do you do the red glossy material again?
Up here in the view settings, it's under matte cap. And if you click, you'll find the red glossy one.
All right, thank you.
Think of it kind of like flipping your canvas. If you're working in 2D, right, it's really good to flip your canvas and catch issues early. This does the same thing. This is going to let you catch those issues early. If you jump between the different settings, the matte cap, the studio, you're more likely to spot these issues ahead of time. Maybe I'll just do something like this. This is also a pretty prime candidate for getting subdived. Right, our forms are going to break, but we expected that, and we're just going to come in and start cleaning everything up. This one is definitely a bit more of a pain in the butt, but it's still doable. So we want an edge all the way around. I'm going to start by just selecting all of these. And doing a quick inset. Because we want these edges running all the way around the exterior. A few holding edges here. I'll tighten this up. I know from my reference there's actually a pretty big, this is welded together, so I'm actually going to leave that kind of chunky, and we'll keep pushing. So here I've got a triangle just from where I was messing around and building it up. I don't really mind having a triangle there most of the time. Because we're doing sub D now, we've got to change that. So we add an extra edge loop, right? And we're doing this all sequentially. So we have this extra edge loop that's also making our squares more even and giving us this extra edge to turn and push into more of a diamond shape, right? So now we've got this big triangle using that same diamond technique. Boom, 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 right? Can mirror that over to the other side. Same thing on this side, right? Now our squares are even and we can get rid of this triangle. Move that up. Pretty solid sub D mesh. If I wanted to hold this edge, same thing. Let's just move this down. This piece I kept in there just as like a, it doesn't need to be actually part of the same piece, it just helps it when it's moving around. We'll isolate this, turn off the subdiv so we can get a better look at it. Start building up big quads first. So take our block out, build up big quads first. As far away as possible. Big quads, just like Ronnie Coleman. I'm using snapping all the time when working like this because it guarantees that everything is lined up. Okay, we have our big quads, check, holding edge, check, holding edge. Fantastic. I think I deleted the bottom by accident. Same idea still applies. Quad, quad, quad. Okay. So that's the basics of sub-D. I'm hesitant to show you this next bit, but I think I will because it can help. I want you to understand how sub-D works and everything like that. Now I'm going to show you how to ignore everything I just taught you. You should still remember it, very important stuff, but this is the other way to use subdiv. Remember, the key thing we're doing here is adding holding edges, right? And we have our basic holding edge shape. And they're not going to be able to see it on the recording, but if we put it here, that shape looks something like this. And we're mostly focused on this bit here, right, where we have the different edges on each side so that it can collapse a little bit better. Manually is how we normally put all of these shapes in, but let's say we have a particular shape. Let's just say the other wheel. It's a pretty good example. What do we know about this wheel? Every bevel, every edge that's catching light is more or less the same. I don't need a ton of control over like, oh, this edge needs to be rounded this much and this edge needs to be rounded that much. So what can we do to create our holding edges? We can proceduralize it. Super simple. Get rid of the mirror and the shade smooth here real quick, and I'll just make it flat again. How can we proceduralize this? Well, we have this fun little modifier, one you're very familiar with, the bevel modifier. And normally the bevel modifier is going to create bevels with actual detail. But we can have the bevel modifier just create geometry for us without actually changing the silhouette of our shape. So if I go ahead and select profile, you may have used this before, custom profile to create intricate shapes, but profile is actually how much the bevel is going to affect the shape. Set this to weight. So a profile of like 0.5, it doesn't really show because it's a graph editor, but a profile of like 0.5, you're going to take here, you're going to take here, and we're taking like a half point and we're arcing between the two. That's how you get the bevels the way you do. If we set it to like a lower amount, like say 0.2, we're going to end up with the opposite. We can just set it to 1, where if this is our corner, it's like this. But the bevel modifier still has to add the geometry. So we end up with something like this. Look familiar? Looks just like this. So we've gone from creating a bevel with bevel detail to creating a bevel that just creates our holding edges for us. So I'm going to go ahead and set this to weight. So limit method weight. And now on each of these edges that I want a holding edge, I'm just going to normally I have a hotkey for it, but I will show it the old-fashioned way. You're just going to go up here to mean bevel weight. Okay. So under your item panel, hit N if it's not open. Item, mean bevel weight. You can hit 1. Boom. Now you see this bevel only affects the things that have the bevel weight. That's why it's beveling there. So I can reduce this amount. And let's set the shape up to 1. Okay. So you see my bevel's gone, right? But if I turn on the wireframe, my edges are still there. So we can go through and select all of our different ones. And normally, I would recommend if you're going to use this workflow ever to make a hotkey for it, because it's kind of a pain to go in here and click this. Normally I just hit QS. We can go through and for every single one, Yep.
I think Shift E does what you were trying to do.
Shift E creases, slightly different, slightly different. That one is for subdivision specifically. We use holding edges because it's easier to control in the long run. Creasing is an option, but we don't teach it because it's Blender specific and kind of annoying. So now I've marked all of my edges. I'll mirror them over. Marked all my edges. You can see it's creating these holding loops. I'll just make it a little bit smaller, maybe 0.1. Right? We set the segments to 2 because, as we discussed earlier, we need 3. So you have your starting point. One edge on each side makes the 3 magic number. And now if we go ahead and add our sub D, it's going to hold just like when we added those edges earlier, right? So it looks like I missed an edge on the inside here. We can just quickly turn this off, select, mark. Okay. It's just as if we did everything by hand like I did earlier, except it took way less time. And we still get the same result. The best part. So I don't have my add-on installed, but there's an add-on called HardOps. And HardOps has an option that lets you immediately mark all of your sharp edges as bevels. And I'm sure there's a way to do it without, but I'm not sure what it is because that's how I've always done it. So you can very quickly just click 2 buttons, mark all your bevels, and then just like kind of how we've done before, let's just pretend I've already marked all my bevels. So 1, 1. We can now just copy everything over to other objects, right? So I've taught you about how we can link modifiers. If I just click these 2, link, copy modifiers, now this high poly is done. Let's go mark all of my edges on this one. This works especially well with hard surface props. Again, I'd highly recommend adding a hotkey to mark these edges because it speeds things up drastically. Fix the topology here a bit. Mark. Other way you can do is just kind of go select sharp. So if I select my sharpness, sharp edges, set this to like 45. And then I think this does it for all of them, I would hope. Yep, there we go. So that's a lot faster. Same thing. Just gonna select something that already has those modifiers, Control L, copy them. That's another high poly piece done. Right, and maybe I just want to increase the bevel size on this one because it's a larger piece, so just bump it up to like 0.2. We have some issues because I've got a bunch of n-gons, but you could pretend those weren't there. This piece wasn't meant to be sub-D'd, so there's issues. But in your case, if you had, like I said, these 2 objects, for example, or any other object that you've already made quad-based, it wouldn't be a problem. I'll probably do this piece the other way, though, to show you how that works after the break. So yeah, use a combination of both. Please understand how it works before you just jump into creating all the different like bevels and subdivision. The big part is it's got to have an even bevel all the way around for that technique to work. Right? Blender's not too fond of modifier stacking, where if you have like 2 bevel modifiers, you can control each one individually. There are ways to do it for sure. I do work like that sometimes, but for the most part, it only works when you have something that has even edges all the way around, right? But it's very fast. Okay, cool. That's kind of our break time. Maybe at like 9:50 we'll start the second part, and then we should be able to get out here like 10 minutes early. Any questions though while I'm here? I guess that's here for you. All right. I'll pause this for right now. So let's jump back into it. This will be the last portion, maybe like an hour 20, hour and a half, depending on how much we get through and how quick it is. Hopefully we can get out a little bit early. I went backwards in the slides to show the model. Forgot about that. Okay, remesh and sculpt. So this is a combination of a couple different workflows. I'm I'm going to show you everything I know how to do in Blender first, which is the majority of it, but Blender does have its issues for sure, and there are features that are missing that I don't know if they've added them, but as far as when this workflow was invented, it was only really possible in ZBrush, but we'll try it in Blender. And this one doesn't require good topology or anything. So what changes when we come to our blockout? For the subdivision, we just talked about how we need to take our blockout and turn everything into quads, right? And that's possible with a lot of things. Sometimes it's just slow. Take a look at this piece, a big long piece. I could spend time turning that into quads, no problem. It's not like it'd be complicated, but it would just take time. I don't really care for all that time. And other pits, it's a big piece, which means we're gonna want more detail than just like a round edge here, right? That piece is super noticeable, and when we're looking at the prop, that's the kind of piece that's gonna get damaged. That's what's gonna get dinged up. That's where somebody's gonna kick it with their steel toes, or like fall on it, or like drop it on the ground by accident, right? That's where all the issues are gonna happen. How do we get that kind of detail? Well, we have to do a little bit of sculpting work, right? We'll explore what that looks like later in Blender and in ZBrush, but we can add extremely minute details, even tinier than the bevels that we're creating for subdivision. So how does this look like in Blender? Well, we have to go into sculpt mode to be able to access the remesh feature. What remesh does, I don't have a great slide presenting the math for this one, but it's going to voxelize your mesh. Voxel being basically a pixel, but in 3D, for lack of a better way to put it. So we can select the size of our voxel and create a bunch of cubes that cover our mesh. Then it will cut all of those cubes into the mesh, and you end up with a mesh made of cubes. Sounds crazy. It makes more sense when you actually take a look at it. So if we look at something like our new base mesh, right? So just like the example from before with the subdivision, we're doing the same thing here. I've got a base mesh, right? If I remesh it, you'll see it's now a bunch of tiny cubes where the actual voxels would intersect with the object, right? And then if we use this filter called the smooth, we can smooth our mesh out, right? And we end up with a sub-D-like result. Two key differences though. One, we don't have holding edges. So we don't have a ton of control over the different amounts of wear on each edge. And two, the remesh, it's a lot harder to control the topology later when we're trying to do individual bevels and things like that. But we can remedy that with a few different tools, right? Okay. One of the main problems that comes with this technique is if your voxel count is low, right? So I just started with this random object I made, and I used a pretty low voxel size of like 0.1, right? The other issue with this is we don't know what number of polygons we're going to end up with when we voxelize. We can estimate roughly, but we don't actually know. So if you make your voxel size too small by accident, boom, 6 million polygons, and it breaks. You can no longer do anything, right? But if you make it too low, then the voxels are going to overlap different parts of your mesh and try to connect those parts, and you end up with this absolutely broken looking mesh. Quite brutal. One way to fix that problem is to add a ton more voxels, right? So this is the mesh, this is the vertices, it's like pitch black. My computer came to a screeching halt every time I tried to do anything on it. And this is why we don't really typically want to use this technique in Blender. I'll go over it with you anyway, and we'll take a look at what we can do to make it work, but this makes the mesh much harder to work on. Not fantastic. Right? The other issue, so this is the remeshed mesh. Before we add the smooth filter, everything is hunky-dory except our cylinder is still a cylinder. Because of the way that it's going to isolate and add detail on these voxels, it's going to maintain those sharp edges even after we smooth it out. That's kind of a bum. We don't want that. This should be a cylinder, right? The solution in Blender is quite simple, but also problematic all at the same time, and that is before you go remesh it, make sure that your cylinders are all cylindrical. And how do you do that? Well, you could use a subdivision modifier, but then you've defeated the whole purpose of this technique because you have to go fix your topology. You could just isolate that part and make a good topology out of it, but that takes a lot of time. So the solution really, unfortunately, is ZBrush. Now ZBrush makes this quite simple. There's a variety of techniques that we can use to create these hard edges very quickly. I am going to show you both, don't worry, because I don't expect you to buy or use the free trial for ZBrush right now. I would recommend it, highly, highly recommend it, because it makes life 10 times easier, but we'll go over how we can do it both ways. Sound good? Cool. So I'm going to just duplicate that big part, and we'll kind of take a crack at how we can use both techniques. So I'm just going to start with Blender. We'll duplicate this, pop this up. For Blender, when we're talking about remeshing, we don't actually need to do anything. The way the voxels work, they don't care about your existing topology. They're just making the shape, right? So I don't have to do a single thing to prepare this for remeshing. When we put it in ZBrush, we are going to have to make some extra changes to make sure that it understands it properly. So we'll take this one, go ahead and open sculpt mode, pop on in. I would recommend leaving the wireframe on if you can, just helps you kind of understand what's going on and you can find the errors quicker. We'll take a quick look at this, go okay, our mesh is looking all right. Let's hop into remesh. So we're immediately presented with voxel size, adaptivity, fixed poles, volume, attributes. The main one here is preserve volume. That's the one that keeps it in the same form as the existing one. If you don't preserve volume, it tries to use as much of the full voxel as possible. So if we look at this example, it might be a little hard to see on the screen. There's like these tiny rectangles just along the edge, and it's because the cube of the voxel isn't perfectly lining up with the edge of the cube, right? So instead of extending it to fit the voxel cube, it's cutting it off, and we end up with this rectangle, right? So preserve volume is going to help keep our mesh the exact shape that it is when we give it to the remesher. The only other one you really need to be aware of is the voxel size. And quite simply, it's how big each individual voxel is. So if we have an object like this that is modeled to real human scale at about, it's less than a meter on every side, we can roughly kind of estimate how many voxels we're going to end up with and how many polygons when we go into remesh it, but it can be tricky, and this is kind of a pain in the butt. You can use this sample detail size where you make a mesh on the side and that you know is a good size. So for example, if we make a new cube here, it's like roughly the same size. This cube is way less likely to crash our computer. These are all extra steps that you just have to kind of use in Blender, and that's why it's a pain in the butt, because we don't really want to do all these extra steps. But if I remesh this cube instead, which is not going to crash my computer, right, we could try 0.1, remesh. Okay, this is looking not too great. I've got an error there because I forgot to apply scale. Back into sculpt, let's try this again. Maybe we go 0.05, so we cut that voxel size in half. I would recommend, again, going step by step like this, because if you just suddenly decide to bump it up, your computer will crash. Right, so fantastic. This looks okay, but it's generally too low. Pump it up again, 0.01 maybe. 0.01, remesh. That's looking a lot more like the detail we need to start sculpting. Okay, I'd even maybe go higher than this, but we can start with this and we can always add more later. So now we pick our object, we'll go in, sculpt mode. We know 0.01 is roughly correct. We can remesh, right? We take a look and, oh, we have more detail, so it's not going to be enough. So we can cut it in half again, 0.05. Still not quite enough. 0.01, cut it in half again, remesh. Now my computer's starting to crash, but it looks like we're doing okay, right? And what are we at right now? We're at 700,000 faces. And already Blender is starting to crawl to a halt. When we open ZBrush, I'm going to be going up to like 6-7 million, and it will run on a Dell from like 7 years ago. Yep.
What version of Blender are you working on right now?
This is 4.43.
I'd be curious to see, because I know 4.5, you can run Vulkan backend. So it can probably support a little bit higher quality.
That would probably help. I think this can actually run Vulkan backend as well as a 4.43.
I just know it, like, it's put, like, a full release came out at 4.5, but like I think you can.
Yeah, it's I'm not sure exactly what end it's using that for, because the Vulkan backend is more for the rendering stuff than the computational stuff.
Well, yeah, I just think like from what I found, viewport stuff as well.
It would be a lot faster. Yeah, that makes sense. I'll probably leave it on OpenGL for now. That's something to explore for sure. I haven't really gotten too into the nitty gritty on that stuff, but if that does help, that would make a huge difference, because as soon as I start running the polish function, you're gonna watch this thing like crawl. So we do have a slight issue, right? I should have rounded this out more. We can always undo this. It's another one of those issues. You just kind of got to go back and forth until you know what you got. So maybe we take this edge and we just round it out a little bit more. Okay. That looks a little bit better. Still not going to be perfect just because it's impossible for it to be with the Blender technique. Let's remesh it. 0.01 again, or 001 was it? Yep. Okay, cool. Now up in the corner, I'm gonna turn off the wireframe so we can get a good look. Okay, stuff like this is annoying. We can fix it, but it just takes a little bit more manual labor. So under Sculpt here, you'll see Smooth, and Smooth is a filter tool that is going to apply to the entire mesh. So this is another one of those ones where we're going to get even bevels throughout. The difference between this and using these bevel modifier plus subdivision is with this technique, we can always just sculpt more bevel after. So if we want one of the edges to be more beveled or want to add like welds into certain areas, we can just do that super simply after. So be careful with this. If you use this smooth thing, once you click, so I'm now pressing, it's applying. As I slowly move my mouse, you'll see it's smoothing out all of those edges very slowly. Because if you go too fast, it will like stop working and your mesh will collapse in on itself and then explode, and that is a pain. And the other issue is, it's not like the other tools where you go forward, it goes forward, it goes back, you go back. There is no back. So if I just keep going and it's smooth and I want to go back, I cannot go back. There's no back. I have to undo it and then try again. So down here, sculpt, smooth. The other option is just run it like a tiny bit to pop the window up, and then you can kind of work on it down here. So we can do like 4 iterations at like strength of 2, maybe 3. Take a look, need a little bit more. Try and create these smooth edges that way, right? It's not fantastically smooth, so we can come in after with our brush and just kind of smooth out all the parts that are lacking a little bit. We shouldn't have to do this part. We won't have to in ZBrush, but that's just the nature of doing it in Blender. So we can smooth these out, and that'll kind of help with our faceted faces and the edges and stuff. Okay. And the goal with all of this is we're giving ourselves a nice base mesh to use for our sculpting. So I know that there's like welds here, so we can make these much larger. I could turn on the mirroring if I really wanted to, symmetry, right? But we still have this issue, right? I would have needed to make this rounder before remeshing for this technique to work. So instead I have to come in here and manually round this out, which can lead to errors and uneven shading. So not fantastic, just this is how it works in Blender. There might be better ways. If you know them, please feel free to share that information. I'm not entirely familiar with doing this stuff in Blender because that's not very standard. So there could very much be a better way to do this. I'm just unfamiliar. Okay. For something like this, I think it's actually kind of okay because this, again, is another big piece, and it would be beat up, right? Probably this thing's had stuff fall on it, so it being super uneven as far as like the shading goes is kind of okay. It just makes it look more like dented metal, which is kind of what you're going for anyway. Right, so now we've got this smooth, nice bit. We can introduce Dino Topo. So in Blender, we have this thing called dynamic topology, different than ZBrush. I think it only exists in Blender, as far as I know. I'm not sure any other program does this. And by clicking it on, okay, it's freaking out because I have this shade smooth on. I can just get rid of it. By turning that on, what's going to happen is it's going to add extra geometry when I make a brush stroke. So right now I'm just on the default like brush, right? But you can see it's messing up the mesh. And the reason for that is because it's adding geometry in places that I don't want it at a detail that's not high enough. But if you click, see, it's now changing the topology literally just where I'm drawing. When you undo, it undoes entering Dyntopo for some reason, which is really annoying. Detail size, right? We can shrink this down to like 1, and now you can see it's adding topology. If we put it at like 5, we're lowering topology. Again, the issue with this is there's no easy way to just know how much you need. 2 looks like it's keeping it identical to what it's at. So let's just bump it down to 1 so we can start doing some more specific work. So we know it's at 1. We know when we draw, we're getting extra detail. I can go ahead and turn off my wireframe now so I can see. And we can get to work on super specific edge detail and stuff. So I can come in here and maybe use like some kind of cutting brush or this scrape brush. You can see my computer is absolutely struggling to do anything with this. And it looks like our topology is too low again because it just loves being different. Oh, no, it's okay. All right, but this area that has more topology now is going to be more firm. It's going to maintain its shape better when we smooth it and stuff. And we can add edge wear and things like that. I'm sure there's a brush that's good for like edge wear in Blender, but I don't know it. So I'll kind of just beat this up the only way I know how. Right. And while I'm sculpting these details, I'm thinking about how this mesh would be in real life. Like, where is it going to be damaged? Not here, right? How would it be damaged there? Somebody would have had to like flip the thing over and then shot it with a gun in the bottom for it to be damaged. It's not going to happen, right? Your outside edges, the exterior bits, corners like this, probably destroyed, probably bumped into walls or something, right? Bottom, same thing. Maybe a little bit less so because it's less external. This corner also banged up. Right? And we're just going to go through and add this detail throughout. The inside of this, right? Thinking this is the inside, that's where the lever is going up and down. There's probably, because the lever's down most of the time, not room for stuff to get in there and damage it. So we're not going to worry about this too much. There probably wouldn't be that much damage along this edge. Right? When we get to these wells, or the wells that are supposed to be here, we can go ahead and use a different tool to sort of start building up wells. That's not the one. This one. Yeah. All right, so we can start to sort of sculpt in these specific well details. This stuff would be impossible with subdivision, right? You're not making topology to get a well done. I say impossible, I'm sure there's some crazy people out there that do it, but for our purposes, it really doesn't make any sense. Right, but every time I lay a brush stroke, my computer has to catch up. I'm just genuinely not having a good time. And if you're not having a good time while you're working on this stuff, you're not going to want to do it anymore. But you can't argue with the result, right? Now we have a much better looking high poly prop. We've got our nice polished edges. We've got nice intricate details and parts that are damaged. All of this will be baked down to the low poly because we duplicated it off. So what's left to do with this one? Well, it's currently sitting at 101.9 million polygons, which I'm shocked that it's even running as well as it is. But when we go to bake this, we do not need 1.9 million polygons. It's super excess. So what we can do instead is add a decimate. This is also going to lag pretty hard, but if we set this to like 0.5, eventually. Okay. Cool, so we're now using half the geometry, so now it's at 1 million. But you notice our silhouette and our shapes, they really have not changed, right? Our shading is more or less identical. So this is just one more optimization. When we actually go to bake this down, we don't need to bake all 2 million polygons down. We just need to bake the specific shapes down. So it doesn't matter As long as we don't collapse these edges and things when we go to bake, we're okay. So I can drop this down to like 0.25 and we can take a quick peek. And by quick, I mean about a minute because it has to calculate everything. Okay, we're at 0.25 now, which means we're at 600,000 triangles, all the way down from 2 million. Much better, right? Now we've got isolated detail where we need it, but the parts that are flat and gonna bake down flat, they're much less. Why do we bother with this, right? Well, A, saves us a lot of time when we're actually baking because it doesn't have to calculate as much. And B, it won't crash your computer when you try to export it from Blender into an FBX file. Yep.
I did this one time when I used physics to mesh a blanket.
Yep.
So I made a plane.
Yep.
Put physics on it, put collisions on it, and then I subdivided it to a tile, dropped it over a bed, had it kind of ruffle and mold, and then I shaped it, and then remeshed it. It was messy, but it was better.
Yep, that's a pretty standard technique for that kind of thing, getting those kind of soft body stuff done, because just making that stuff from scratch is brutal. So you just simulate it, remesh it, and then decimate it, and you end up with something. If you look at game models that are organic and come from sculpts originally, you'll notice they're always just pure triangles, and it's because they go from sculpt, they use a different workflow. They go, I just use the God of War one as an example. See if I can find the same example. Not that. Struggling a bit. I guess we'll use Sarah Wang's instead because I'm sure it's a similar process. So these props, the way they did for God of War, for a lot of them, if I can find any sculpts, please. No? Okay. These would have been sculpted right from the get-go. There would have been no low poly to begin with. They would have just immediately started sculpting all these organic shapes. So hopped right into ZBrush, use a sphere, and then just start sculpting everything out. Then we just decimate everything down and bake the normal maps. We'll learn more about this when we do the environment art stuff, but this is the other technique for this stuff. It's just not one we're using right now, but for your organic stuff like you were doing there, Jaden, with the blanket, that's the technique. We just go straight from high poly to decimated low poly. So something like this would just be turned into a bunch of triangles using something like this modifier, except it would be dumbed down to like 0.01 or something. So it would take something from 2 million to like 2,000. So if we take a look at this, 0.01 on 2 million is still too many for this prop because that'll be like 20,000, but right. If we go down to like 0.01, we're slowly going down. I'd recommend going step by step. It takes longer, but you're less likely to crash and break everything. Also save before you do this. I didn't. Probably should. So if you imagine we sculpted this prop right from the beginning, right now we're getting closer and closer to what we can actually use in game. So I'm going to cut it down another 10%. And we should end up with something like, I don't know, 9, 10,000 maybe. Once it loads. Cool. So now this is something that we could use actually within the game. For a small prop like this, obviously you would never do this, but if you're sculpting things like rocks, mountains, trees, anything like that right from the get-go, you can use this technique. It's a lot faster. Like I said, I'll cover this more once we get to the actual environment art portion of the course, but for now, we're just focusing on this stuff, okay? Any questions about doing this stuff in Blender and the workflow generally to get to this result? He was very upset this was the wrong class. I think this is more fun than whatever class he was about to go to, but that's just me.
Yeah, I guess so.
Right. Does everybody feel comfortable with this? Do you think you could do something like this for your props? Yeah? Cool. It's not too complicated of a process. As long as you follow it step by step, it should be okay. As far as adding like the sculpted details to make it look good, that's just practice. It'll take some time. So I'm going to delete this so my Blender doesn't run like shit. Okay. Now let's explore the much more fun version of this, which is ZBrush. I'm going to use the exact same prop. I don't have my bridge installed here, so I'm just going to have to export it. So I'm going to grab my prop. Oh, Sorry, there's something we need to do first. So ZBrush, we have to do a little bit of setup on our blockout mesh that we don't have to do for Blender, but we end up with much better results. So the first thing we need to do is ZBrush does not like n-gons. It interpolates them. I keep struggling with that word. It interpolates them a lot differently than Blender does. So let's just go in here and we're going to try and triangulate everything up best we can. No n-gons left over. Triangulate that, mirror it. I'm going to do a select faces by sides. And we can set not equal to 4 or greater than 4. We can find where all of our leftover n-gons are. So we know we have some here, triangulate, and we know these are n-gons, triangulate. Okay, anybody else? That is it. Cool. The next thing we're going to do is kind of like the bevel workflow. I'm going to go ahead and isolate all of my sharp edges, which I could do manually like this, which takes forever, or I could just select sharp. Oops. Select sharp edges. Take a quick look. Some of them we don't want selected still, like these ones. Anywhere we want to be round, we're going to leave unselected. Is anybody considering using the ZBrush trial for this? Aiden, maybe?
Well, I mean, I have ZBrush.
Okay, you know what? That's an interesting point. Let me say this. I don't care where you get it from. I can't provide you links to get it from somewhere. But if, let's say, Aiden was to have that link, you know, I shouldn't be saying this on recording, but yes.
I think since you're a professor, you can like push this to the university board to add the ZBrush to.
ZBrush doesn't do it.
Never mind.
Yeah, it's not the university board. It's ZBrush themselves. They don't really like Durham College pays out the wazoo to get ZBrush for all their students. It's insane. ZBrush's idea of a student discount is pay some now, and then when you graduate, pay the rest.
Oh,
so
Jesus,
it's more of a loan than anything. It's not really a discount. So, yeah. Anyway, good point. I would highly, highly recommend you get familiar with the software through any means necessary before making a purchase. What that looks like is entirely up to you. So let's carry on. I'm going to unwrap this mesh. A little bit weird. I'm going to mark seams. Whoops. So let me mark these as seams. Mark seam. There we go. Okay. And I'm going to unwrap this using my seams. Kind of weird, I know. But now I've got all of the different pieces. Oop, looks like I've got some issues. Okay, unwrap, no problem. I don't know what this is, but honestly, I don't care. It doesn't matter. Oh, I know what it is. Yeah, it doesn't matter. Even something like this, it doesn't matter. We don't need good UVs. We literally just need to separate all of these by a seam, right? So anywhere we have a sharp edge, that's where we're going to put our polish, our bevel. We need to separate that by a seam so ZBrush understands that this is where our seam goes. In Maya, we call these face sets, and they use like shading techniques to make sharp edges on all of the different things. We're not using Maya, we're using Blender, so we have just marking everything as seams. Okay, unwrap it, boom. Now our blockout mesh is ZBrush friendly. I'm gonna go ahead and export it. Is anybody familiar with the differences between OBJ and FBX? I imagine some of you are. If you did CG, you had to write your own OBJ loader. Yep.
OBJ, in Microsoft, they have their 3D modeler, 3D model viewer. So like if you have an OBJ file, you could open up and look at the model. You can. That will open other things as well, other than just OBJ. But what it really boils down to is simplicity. FBX is a binary file format, which means it can compress things a lot more, and so as a result, they shove a lot more data into them. FBX can include things like your materials and other information. The issue is that means there's stuff that you can't control or understand. And when we're working with making these high poly meshes, we want to be able to control and understand everything. So I'm not going to use an FBX right now. I'm going to use an OBJ. When I'm dealing with just mesh data, so making a high poly, something like that, OBJ. When I'm exporting this for the game later, FBX. It's all about using the minimum amount you need to get the job done,
and then moving on. So I'm going to include selection, UVs, normals, don't need colors, don't need this, don't need to triangulate because we already did, don't need any of this, don't include materials, don't do anything. I just want where the vertices are in space. And if I go to desktop, I can just save this here. Right? Because this is easy to understand. There's nothing that can get in our way here. If you took CG, you literally had to write an object loader so you understand the format of this. If I can just open with and Notepad. Right. This is what an OBJ file looks like. It is quite literally the name of the object and the position of every vertex. And then eventually the position of every vertex normal, and then eventually the position of them in the UV space as well, right? And this is the triangulation part. So when I'm talking about how the different things triangulate things differently, VT is which 2 points are going to be turned into a triangle. So some things might determine this a little bit differently when you import them, right? I forget what S stands for, it's been a long time. And then your face sets. So vertexes 71, 63, and 16 make a face. Right? I'm not going to go over this too much. It's not super necessary. But the fact is, it's like those commercials when they're trying to sell you food, and it's like you can understand all the ingredients because you can read them. Here with OBJ, you can understand everything, which makes it optimal for doing this kind of work. Just pop open ZBrush now. And I'm just going to go ahead and open our blockout object. Actually, let's just make a new file instead. So let's find cube. So this is ZBrush. The interface is garbage. If you've never used it before, it's like looking at just a wall of stuff. It's honestly, it's much harder to get into than Blender. Blender's UI is now much more friendly than it used to be, so it's a lot more user friendly. This is brutal. If you want ZBrush help, like definitely reach out to me. I can help you along all of the individual things, like knowing where everything is. So every single one of these panels has like 30 options under it. Subtool, bunch of options. Geometry, bunch of options. Array mesh, bunch of options. Nano, thick skin. So it's a lot. I'll try and go through this quickly, but also explain so you understand. We're going to start by going under subtool. This is, think of it as our like object viewer. This is where all of our objects are living. I'm going to go ahead and this is where we can import different objects. So I can append objects like this cone, and now I've got 2 objects in my scene. I can move them around and sort of build up shapes. So this is how people build up things right in ZBrush. They don't actually need to start in like Blender. You can do some basic modeling in here to get started. It's been a long time since I've actually done anything other than use the bridge to get objects in here, so I need to remember where importing objects is. There it is. So let's delete the cube. It'll give us this star, which is a default object. You have to have something in your scene or it breaks, and I'm gonna hit import. Desktop, week 1 blockout. Cool. Okay, and here it is. So because we triangulated it, we're not getting any issues. And now this other goofy bit, we use those UVs, and now we can create object groups for each object, or for each face set, sorry. So also something that I just normally have available at a moment's notice on a hotbar, and now need to find amongst the thousands of menus. But polygroups. Auto groups with UV, so this is building off of those UV islands. So now you'll see it changes color for every UV island we made, right? This is key, because later when we're using the polish tools, what it'll do is it'll only polish between islands. You can kind of maybe see where I'm going with this now. So we have our polygroups, we're all good there. Our blockout is ready to be remeshed. Somewhere in the options, Dynamesh, there it is. So we have Dynamesh. There's normally an add-on I would use that lets you set the number of polygons that you're targeting. So for something like this, I would go for like 2 or 3 million. Instead, we have to use the resolution slider because I don't have it installed. So let's just try 190 and see what happens. So Dynamesh, literally instantly, compared to how long did it take in Blender, like a minute. Resolution, let's bump this up. Dynamesh, still too low. 500, Dynamesh, it's looking a little bit better. Like 700, Dynamesh, still kind of too low, right? We're sitting at like 400,000 right now. I want to go for like 2 million. So let's try 1,200. There you go, 1.3 million. Sweet. Still took 2 seconds, no time at all, right? And now we've got essentially the same as what we had in Blender, right? Where it's voxelized down to a bunch of tiny shapes. But the difference is in the polish function. So here we have a polish function as well, but there's a second one. And this polish function we want polished by groups, or polished by features. Yeah. You'll notice our parts that were problematic in Blender because we left them as really low amounts of topology. When we use polish by features, it's going to polish within each face set group. So it knows to polish not here in the corner, but here and round out whatever shapes it's on. So we can run this a couple times. And now pieces like this, they've become way smoother. So run this again, one more time just for good luck, right? Everything else is more or less the same. Our shapes are still good. There's a little bit of weirdness in the corner. We could go change the topology if we really cared, but it's going to be polished out anyway, right? And I'm going to use the other polish feature, right? And it's going to do the same thing that we kind of did in Blender, but now we still have these round shapes. Okay, so this is where we were in Blender after like 10-15 minutes, and I think it took less than 5 in ZBrush. So would really recommend. And also it's not lagging at all, right? Like I'm working in real time. I'm actually enjoying what I'm doing. Let's do something like a trim dynamic. Shrink this down, and we can kind of come in and do the same thing. I'm gonna start adding, right? The brushes are also just fantastically way better. We can get in here and start cutting things up. We can use something like this to build these welds, or maybe like a just standard clay brush. Right, super loose and rough, but we can kind of build it up after. Get in here, work detail by detail. I don't really know what welds look like without reference. I'm not a welder. I assume it's something.
I think it's like a brush. You click on the brush, then you just click it all over the circle. That would probably look like that.
I think for these kind of things, they usually do like MIG welds, but I don't know enough. Okay. But like, great, we've created something welded together. Kind of looks bad, but if I had a reference photo, it would look good. Right, and we go through and we do all the same thing. Use different brushes, create edge damage, corners. If you see me just quickly doing like that, I'm switching brushes. The brushes are all bound to hotkeys that are based on their names. So like this is clay buildup, you hit brush, C for clay, and then B for buildup, BTD for trim dynamic. So that's all I'm doing. If you see that, is just I'm switching brushes. Not something you really need to know. Right, and I can go through and add my edgeware. Edgeware, edgeware, edgeware. Okay, and this process might take a while, but you'll end up with a much better result. And you're just thinking about like the type of material, right? Like wood would probably not cut quite like this, right? This is like more of a dented metal kind of thing. Or you might want to come in with like a sharp brush to kind of cut into the metal, which is more how, you know, metal might move if something like falls on it or whatever. This isn't a great brush for this, but something more along those lines. Just adjust the strength. Okay. Something like this. If you have a drawing tablet, this is like a prime time to use it as well, because there is pressure sensitivity. You're gonna see me going like this a ton because I'm using a mouse right now. Like, so to get different amounts of depth on my cuts, I've got to change the intensity a bunch. If you have a drawing tablet, that makes this much easier. Okay, you don't want to overdo it because we can also do this in the texturing phase, but just getting some nice edge detail. Okay. Any questions for this kind of thing? I imagine no, because you've never used ZBrush before, so you're probably just overwhelmed by everything that's just happened. It's just understandable. Like I said, I'd highly recommend using it because you can get some incredibly detailed high polys. But other than that, that kind of ends it for this week. The process for creating the low poly from ZBrush is identical, right? We're gonna, afterwards, we're done, we're gonna go decimate it just like we would. So I can go ahead and pre-process and then decimate this. This part does take a little bit longer, but you end up with some really nice meshes. Their ideology kind of is you can work as fast as you want, and then when you're done is when all that time buildup is. So it's much slower with the whole like decimating and everything, but once it's done, we're at 1.3. Go to decimate. I can decimate this down to like 3,000 for a low poly, or if we just want something that's easier for baking, we can lower it to like 100,000. Decimate. It'll take a little bit of time. You see, again, our silhouette doesn't change. It's the same thing as we did in Blender. Now we have all of our isolated topology. We can export this and use it to bake. How do we bake? Excellent question. Tune in next week, and I'll teach you everything you need to know about UVs and baking, and we'll go from there. Okay? All right. Have a good rest of the day.